In the last video, we started talking about MassFX, which is 3ds Max's built-in physics engine, and we had gone over dynamic rigid body, kinematic rigid bodies, and static rigid bodies. So today, let's continue with that by going over some constraints and mcloth. Last video, we also went over biped and ragdoll. So what I want to do first is go over some of the constraints. I'm not going to go over all of the constraints, but we will go over some of them. So I'm going to create an object, go into the Create tab, going to choose a sphere and a box. I'm going to create one of each. I'm going to make sure that my objects are above my ground plane. And I'm going to make both of them dynamic rigid bodies. And then what I want to do is I want to constrain these two objects together. So what I'm going to do is pick both of these objects, and then under my constraints, which is right by the mcloth and by the ragdoll, I'm going to click, hold, and create rigid constraint. Now this display, this white display here, is so that I can get into my properties of my constraint. And here we see that my parent is the box because it's the first one I chose, and the child is the sphere. That's not how I want it to be. I want the sphere to be a parent and the box to be a child. So what I would do is if I was creating it, I would choose the sphere first because you want to choose the parent first and then choose the child. But here under the General tab, in my Modified tab, because I'm modifying what I've already created, I'm just going to switch those. So now my sphere is the parent and my child is the box. So let's run a simulation and see what this does for us. So what we see in our simulation is that our sphere fell and then the box along with it, and they both fell together and rolled because of the shape of the sphere. Whatever the box did, it was only because the sphere did it. It's because our sphere is the parent. So there we have rigid constraint. There are some things that we can do. If we, for example, wanted the translation, the X, Y, and Z axis to be other than locked, locked meaning it's not going to have its own properties, it's going to inherit it from the parent. Also with our swing and twist. So let's see what we have if we do limited on X, Y, and Z axis. And if we run this again, we can see that although they are linked, the box was able to fall. So let's say our bounce is how hard you rebound when hit. So let's, I don't know, what happens if we change, it's normalized, which means it goes from 0 to 1. And our limit radius, maybe change this to 12. I don't know, we're just trying something out. So there we were able to go down, and then we hit that limit. And it bounced because of our bounce. So let's maybe set these back to locked. Let's take a look at our swing Z and swing Y maybe. Maybe we'll make those limited. And now they're able to rotate. Maybe if we change this to 22. What happens if we change it to 22? Give it a lot smaller radius. And we can see that we're not able to do as much. Okay, so let's maybe change those back to locked. And we'll get in some of these other properties with other constraints that we're going to look at because we have a lot of these same properties. So let's continue. Let's create another type of object. I'm going to create a box. Okay, then create another box right alongside it. And I apologize for fumbling around a little bit. Okay, I've created my objects, so now I'm going to modify them. Make this a little bigger maybe. Okay, I'm going to make this my frame for my door, and I'll set it as kinematic. And then my door itself, I want it to be able to move, so I will set it to dynamic. Now here I'm going to create what's called a hinge constraint. So again, I'm going to select my parent, then select my child, and instead of the rigid constraint, I'm going to choose create hinge constraint. Okay. Now this object here that looks kind of like Pac-Man is the angle in which my door is going to swing and how much it can swing. But what we see is that it's at the corner of our door frame, and that's because that's where our pivot was. If I want to change that, I'm going to go ahead and delete this. And then I'm going to come to my hierarchy tab, choose Effect Pivot Only, and move this to be more in line with my door. I like that, so we'll go with that. My doors are, or my frame is selected. I'm going to select my door, go back to that hinge constraint. And now I can see that I'm more in line with my door. Okay. So let's run the simulation and see what this does. Well, it's not really doing anything. And the reason why is because we don't have anything reacting to it, or reacting with it rather. I'm going to choose a sphere, move this upwards, turn it into a kinematic object, and turn on my auto key, come to maybe frame 30. I'm just going to move this through. Okay. So now if I simulate, you can see that my door opens just as far as the limit will allow. Again, we can select our property, our U constraint property, and if I wanted to swing on the y-axis or z-axis, or if I want to unlock the twist, I can. So swing z is limited. If I turn that to free and then do my simulation again, then we'll see that it's going. Well, it's not supposed to do that. Well, because it's I think I did something a little wrong there. I believe it's hitting the plane. So I'm just going to move this up a little bit so we don't have to worry about anything hitting. Now if I simulate now, we'll see that it just continues to spin. The reason why it didn't spin before is because we're a little close to the plane, so it actually hit this ground plane here. And since it is a static object, it stopped our dynamic object. It's a good thing to see, though, to see that not everything works the way that we want it to. And we don't have to freak out about it. We can just, there's a way to fix it. There's always a way to fix it. If we go back to our constraint object, let's take a look at spring, which we didn't look at with our rigid constraint. So, and the thing that we want to look at here, because our door rotates, we want to spring to resting swing. Spring to resting swing, I apologize. So this is going to try to go back to where it is when the simulation starts. So again, I'm going to turn my swing Z to limited, maybe take that to 180 degrees though. That's a little too much, maybe 120. And then my spring to resting swing, I want to turn that maybe on 5. Now let's see what happens when we run our simulation. So it's kind of like if you've seen an old Western where they go through the saloon and you have the saloon doors. It's going to try to go back to where it was when the simulation started. The higher that number is, the more it's going to try to go, or the faster it's going to try to go back to that resting swing state. So we have it on 20. We try a lot faster. Okay, so we've looked at rigid constraint, a hinge constraint. This time, let's look at a universal constraint. So I'm going to create an object. Create another object. Now let's do a cylinder, why not? Turn my height segments off. So I can make these anything I want to. If I want to make them static, I can. If I want to make them kinematic, I can. If I want to make them dynamic, I can. For most constraints, you'll want to stick with kinematic and dynamic because most of them don't work with a static object. So let's do our sphere or our cylinder as kinematic object, our box as dynamic. I'm going to choose my cylinder because I want it to be the parent, and then choose my box because I want it to be the child. Then I'm going to go to universal constraint. And this here again will show me the size or the arc of my object. So if I were to run this simulation now, you can see that I'm moving a little bit. See what happens if we move over here. Then run our simulation. Got a lot more going on. So here we've looked at a universal constraint, and we can come to our constraint object and we can set our limits again. So maybe 90 and 90, and let's say that, we're good right there. Let's see what happens. So our sphere hit our box, and now we're swinging a little bit more because our limits are greater. Okay, so we've looked at rigid body constraints, we've looked at hinge constraints, and we've looked at universal constraints. I think that's good for the constraints. Now let's take a look at another really fun feature, which is the cloth. So for the cloth, I'm going to go to my top view, I'm going to create a plane. And one interesting thing for our cloth is that it needs geometry in order to look realistic. So the more length and width segments that you have, or the more polygons that you have on your object, the more realistic it's going to look. So I have my object. I'm going to go to mCloth, and I'm going to set it as an mCloth object. Let's see what it looks like by default. So I'm going to move it over the cylinder that we had, and let's run our simulation. I'm going to turn off edges so we can see our creases and crinkles and all sorts of things. So we can see several things happening. One, we've got folds and whatnot, but it kind of looks stiff, and we're kind of cutting through or clipping through that cylinder. So let's reset our simulation and let's look at some of that. We have a lot of properties in our fabric. We do have some presets. Really, by default, 3ds Max 2016 only has one, which is cotton. But what we're going to look at is bendiness, which how much the cloth will bend. It's going to give us that less plasticky look. Stretchiness would be like if we wanted to do, say, elastic or some kind of fabric like that, and I'll let you play around with that. So here, when we run it now, we should see that our cloth looks a lot less rigid, a lot less plastic. So let's run our simulation. Here we can see all kinds of streaks and folds and cuts and whatnot. So we're looking more realistic, but we still need to deal with this here. So let's reset our simulation. And here we're going to go to our collide to rigid objects and our thickness. We want to turn our thickness up. So let's maybe change that to 5. So this is basically how thick our collider is. Self-collision, we can mess with that also, but we're not really having a problem with the cloth clipping through itself, just mainly that object. So we've changed that thickness to 5, and let's run our simulation and see what happens. Still not there, so let's maybe change this to 10. A lot less, we have a lot less there, so maybe change it to 20. Okay, so we have it, but the problem is now is we look like we're on a big sphere instead of a cylinder. But we can play around with those thicknesses, and I'll let you play around with those if you want to, if you're following along. If not, whatever you're creating, you can follow along with that. The next thing that we can start going over is there's an option for our cloth to be able to tear it. In order to do that, we have to go into the mCloth in the modifier list, and here I'll see all the vertices that I have for my cloth. So I need to select whatever vertices I want to make tearable. And you can select whole swatches if you want them all to be tearable, or if you just want certain ones. So I'm going to just do certain ones, and so I'm going to hold down my control key so I can select others. So I'm going to have this plus sign in my tearable. And then I'm going to go to my group and make a tear. So this is going to create a group, and I can call it whatever I want. I'm just going to name mine tear. And that's it. Then I can go back to my cloth object, and I've got my tear group. And after I do that, my allow tearing is on. And then I have tear past, which means if I tear past this amount, or if my mCloth stretches past this tear past amount, it will tear. So, whew, that was a mouthful. Okay, so let's see what happens if we simulate with this tear on. Okay, so that wasn't quite enough. What I'm going to do is turn this thickness up. I think I had it on 10 before. And turn my tear pass down to 1, which is the lowest that it can go. And let's try running our simulation again. And here, we can see that we've gone past the tear amount and we've torn our cloth. Okay. The last thing that I would like to go over is still an mCloth, but instead of using a plane, let's use a shape. I'm going to use a box. And again, we want to make sure that we have lots of geometry for this box so that our mCloth can deform it. So let's say maybe 20, 20, 20. Okay, we've got quite a bit of geometry there. Then I'm going to set it as an mCloth object. And if I run this simulation, let's see what happens. So it looks kind of like, again, like plastic, maybe some thin plastic, but I don't have that bendiness up. So I'm going to turn it to 1, and let's see what happens if I resimulate. There we go. That looks a lot better. And the reason why we're doing a shape is, one, to show that we could have shapes that are mCloth, but also because I want to show enable balloon behavior. So this is going to make it kind of like a balloon, in that when our pressure is high, it's going to inflate. So let's take that pressure to 2, and I'll resimulate, or I'll do my simulation again. And now we've kind of blown up like we're a balloon. And we're bouncy, and we can see that when it bounces, we kind of flatten out. So maybe 2 is a little bit too high. Maybe we'll do like a 0.5. Okay, well that wasn't too good. Maybe like a 1.2. Okay, now I've got a little bit. That's a really neat little looking thing. Now we can also make this tearable by doing the same thing. We go into our mCloth and choose the verts that we want to make tearable. We can do that. So I'm going to let you play around with that. We've gone over a lot of the MassFX physics system in 3ds Max. So have fun playing around with that, and we'll see you next time. One thing that I wanted to go over that I completely forgot about was how to create custom collision inside the MassFX system. So here I have a sphere, and I have all of these bricks, and what I want to happen is I want the sphere to run into the bricks, but they're both dynamic objects. So if I run my simulation, I'll see that they both just kind of fall to the ground. Well, that's not good. So instead, what I'm going to do is create an object and then try to apply custom collision to it to work kind of like a slide. So what I'm going to do, and I'm just going to do this quickly, is I'm going to create a circle, convert this circle, let's make it a little bigger, going to convert this circle into an editable spline. Go to my vertex, select one vertex, break that vertex, delete that vertex. I'm going to go to rendering and create the bigger thickness. And it's okay if you're not following along, if you're just watching, that's okay. I'm going to convert this into an editable poly. Then I'm going to scale this object. So now I have kind of like a slide. I'm going to rotate this by 90 degrees. Now I have my slide. But if I turn this into a kinematic object or a static object, what we'll see is that my collision covers the end of my object. So if I were to drop the ball on it, it would just hit the top and roll off. It would not go into this depression that we have here for our slide. So what I'll do is, first I want to make sure that I have this kinematic, and do. I'm going to change under physical shapes. I want to change my shape type from convex to concave. And what I'll see is now I have properties where I can change my physical mesh. So physical detail, I want 90% of the detail of it. I'm going to choose improve fitting. Now if I generate, what it does is it's created custom geometry for me for my collider. So now if I move this over, and rotate this, and maybe take my sphere and move it, and run my simulation, we should see come in, slide down, what I'm using for my slide, and hits all of the bricks. Let's see if we can watch that again. Maybe it's a little smoother this time. So we'll hit, slide, we'll hit. Okay, that's all for that one.